GCSE Physics boosters, states of matter. If you look at this picture of Percy the polar bear, we've got water as a liquid and we've got ice. Those are two of the states of matter. Now, it's very useful to imagine that all matter is made up of tiny particles. I'm sure you know what atoms are, and there's atoms and there's molecules, basically tiny particles. And this is called the particle model of matter. And basically this model, this way of thinking about stuff, helps us to explain a lot of the properties of materials. For example, the behavior of gases. At A level, we do something called kinetic theory, which is explaining the properties of gases by thinking about them as being lots of tiny little balls bouncing around. We can actually now produce images of atoms with very, very powerful microscopes. There's a fantastic video you should watch. I'll put a link in the description. A Boy and His Atom, where they actually move atoms, metal atoms around. It's very, very good. Watch it. Now, you know this, you did this in year 7, you did this in year 9. There are 3 states of matter that we need to know: solid, liquid, and gas. And for solid, liquid, and gas, you need to know the arrangement of the particles, and you need to know a bit about how they are moving as well. So make sure you know these. This is revision of Key Stage 3, really. In a solid, the particles are close together. There's a regular arrangement, if you like. They're in layers. They're usually in layers. So there's like a lattice of particles. There's a regular arrangement. Each particle is fixed because they are bound to each other. They're joined together. Each particle is fixed. It's not free to move around. And the particles are vibrating. They're not just sat there doing nothing, they are vibrating. If we were to warm up the solid, then they vibrate more. And if we give them enough energy, then they might be able to start breaking their bonds. And we might get to a liquid. Now, in a liquid, the particles are still close together. Okay, just as in a solid, the particles are still closer together. In fact, in water, the particles are closer together in water than they are in ice, which is why ice floats. However, there is no regular arrangement. The particles can move around. They don't have fixed positions. What's actually happening is that they are bound together, but the bonds are continually being broken and made, and the particles are switching positions all the time, moving around. They don't have fixed positions. They can bod around and have adventures. The particles have more energy than in a solid, so they're moving faster. They have more kinetic energy. If they had enough kinetic energy, then they might break their bonds completely and escape, and then you would have a gas. And in a gas, the particles are much further apart. They are not bound together. There are little or no forces between them. In fact, as far as you're concerned, there are no forces between them. The particles have lots of energy. They're moving very, very quickly. The air particles in the room that you're in have an average speed of about 500 meters per second. They're moving very, very quickly, and they're banging with the walls of the container, bouncing off the walls, producing pressure. This is what produces pressure in a gas. So solid, liquid, gas. You need to know about the arrangement of the particles, and you need to know about the movement of the particles, and also how much energy they have. Now, this is an equation that you need to know. Density equals mass divided by volume. I'm sure you know it already. In symbols, we use this Greek letter rho. It looks a little bit like a P, but rho equals m over v. Rho is the density in kilograms per meter cubed, mass is in kilograms, volume is in meters cubed. Okay, here's an example for you to have a go at. A diver finds 500 gold bars in a sunken ship, each of mass 12.4 kilograms. If the density of gold is 9,300 kilograms per meter cubed, what will be the volume of his treasure? Well, pause the video, pen, paper, calculator, have a go yourself. I'm going to show you the answer in 3, 2, 1. There you go. So we've got to rearrange the equation. So volume is mass over density. Then substitute in the numbers. So there's the mass, there's the density, and you should get 0.32 meters cubed. And here's a bit more practice as well. I'm not going to read them out. I will say you should pause the video and have a go at them. I will show you the answers in 3, 2, 1. There you go. And in fact, you can read out the answers as well. Bear in mind that if you had the same mass of solid, liquid and gas, then the density of the gas would be much smaller because it would take up a much bigger volume. Whether the density of the solid and the liquid would be different depends on the material, depends on what substance we're talking about.